1, how can I describe a sequence? Generating and investigating sequences. In the bouncing ball activity from lessons 512 and 513, you use tables and graphs to represent a discrete situation. Today we'll learn about a new way to represent a discrete pattern called a sequence. Samantha was thinking about George and Lenny and the rabbits. When she listed the number of rabbits George and Lenny could have at the end of each month, she ended up with the ordered list below called a sequence. And this is the sequence. And by the way, it's super important. This vocabulary word we're going to need to know. A sequence is a list of numbers. And it always starts with the first number on the list, then it has the second number on the list, then it has the third number on the list, then it has the fourth number on the list, etc. So, and the notation is going to be a little bit unique as well, which we'll see in a bit. But instead of x and y, we're going to use n and t of n. And again, x is now going to be called n, and y is now going to be called t of n. And that just lets us know that we're talking about a sequence. And again, a sequence just means it's a list of numbers. So just some vocabulary just to hopefully make us understand this chapter a little bit better as we move forward. She realized that she could represent this situation using a sequence generating machine that would that would generate the number of rabbits each month by doing something to the previous month's number of rabbits. She tested her generator by putting in the first term of 6, and she recorded each output before putting in the next one. So she put 6 in, it turned into 18. She put 18 in, it turned into 54. She put 54 in, it turned into 162, and so on. So what does Samantha's sequence generator seem to be doing? Well, it seems to be multiplying by 3, right? 6 times 3 is 18, 18 times 3 is 54, 54 times 3 is 162, etc. So what are the next two terms of Samantha's sequence? Well, I think it's just going to be whatever 162 is times 3, and then which will be 486 and 1458. So 486 and 1458 are the next two terms, and I got that by multiplying by 3. Samantha decided to use the same sequence generator, but this time she started with the first term of 4. So what are the next 4 terms? Well, 4 times 3 is 12, 12 times 3 is 36, 36 times 3 is 108, and 108 times 3 is 324. So again, I just started multiplying by 3. Sequence families. So now we're going to break these things up into different families, which will be a little bit interesting. And by the way, if you read through 542, it's going to ask us to do a bunch of other things, which I kind of will go through a little bit. I'm not even really going to jump to the rest of 542. I'm not going to mess with this resource page. You can look at it if you choose to. I just am kind of go through this lesson the way that I want to. So the 3 sequence families that we're going to have are 1, arithmetic. By the way, this is arithmetic. It's not arithmetic. They're spelled the same, but they're pronounced differently. When we perform arithmetic, we add, subtract, multiply, and divide. When we look at sequences, they're arithmetic sequences. 2, we have geometric sequences. These are going to be ones that multiply. So arithmetic are going to be ones that add or subtract. Geometric are going to be those that multiply or divide. And then 3, we're just going to say other, where they don't do either add, subtract, or multiply and divide. So on this one, it looks like I'm adding 3 each time. So I would say that this is arithmetic. Actually, I'll just put an A because I'm going to have to do a lot of writing here. So this is arithmetic, and it looks like I'm adding 3 each time. If I go to B, it looks like I'm multiplying by 2, so I'll say this one is geometric, and I'm multiplying by 2. This one, it doesn't look like I'm doing either, right? If I was adding, it would go 1, 2, 3, which it isn't. If it was multiplying, it would go like 0, 0, 0, 0. So this is going to be other. And what's actually happening here is this is 0 squared, this is 1 squared, this is 2 squared, this is 3 squared. So the next ones would be 16, 25, etc. So I hope you guys see that there. This one, it looks like I'm adding by 1.5, so this is arithmetic, and I'm adding by 1.5. This one, again, I'm not adding because I add 0. It would be 1, 1, 1, 1. It's not multiplying because it would be 1, 1, 1, 1. It would be multiplying by. So this must be other. And it looks like this is kind of a famous sequence. If I add these two numbers, I get 2. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. So this would be 13, 21, 34, etc. Again, to get the next term, you just add the previous two terms. Here, it looks like I'm adding a negative 2 or subtracting 2. So this would be arithmetic, and I'm subtracting 2 each time. This one looks like it's geometric, and I'm multiplying by a half each time. A lot of people look at this as dividing by 2, which is fine for now, but we're really going to want to focus on the multiplying, not on the dividing, as we get through this chapter, and I think it'll become more clear why as we go through. This one, it looks like it's geometric, and again, I'm multiplying by a third, or you could say I'm dividing by 3 for now, but I think, again, you're going to want to get to multiplying by a third. Here, this is other, right? I'm either subtracting 6, but then it doesn't continue there, or I'm multiplying by a quarter and that doesn't continue. So what is happening is it's kind of making this bowl shape. It's a quadratic. It's going to be this kind of a shape here. So as far as the next terms, we don't really need to worry too much about it. It adds 2, then it adds 6, then it adds 10. So I think it would add 14. Actually, I does have some interesting properties. I don't know how much anybody really cares to see them. I show it in class. I think it's interesting, but on this video, I'll probably spare you. And on this one, it may not look like it, but it's geometric, and we're multiplying by 2. If I multiply 5/4 by 2, I get 5/2. If I multiply 5/2 by 2, I get 5. And then obviously 5, 10. So the next ones would be, I don't know, what? 20, 40, 80, etc. So some of the things that they want us to do once we've had this sort of figured out, whether they're arithmetic or geometric or other, now that we've got them categorized, is to figure out like the next 3 terms. And again, a 1/3, 1/9, 27th. At least I think it asks for the next 3 terms. It might not, but that's kind of what we're looking at. The other thing is it wants us to put them in tables. So I'm just going to focus on 1 and 2. So I'm going to get rid of everything else up here that's not 1 and 2, and I'm just going to make a quick table for 1 and 2, so we can, or I guess I should say A and B, so we can kind of see what it is I'm talking about. Okay. So one of the first things that we want to remember here is that we're not talking about X and Y. We're talking about N and T of N. Right? So, and the other thing is when we look at a list of numbers, it always starts with the first number in the list. So the first number of this list is -4. The second number of this list is -1. The third number of this list is 2. The fourth number of this list is 5. And I'll just go with the next 3 terms. But again, I hope you get where this 1 and -4, 2 and -1, 3 and 2, and 4 and 5 is the first number, the second number, the third number, the fourth number. So at this point, I'm just adding 3, so I'll go 8, 11, 14. Those would be the next 3 terms here. Over here, my first number is 1.5. My second number is 3. My third number is 6. My fourth number is 12. And again, so what's the fifth number? Well, the fifth number would be 24. The sixth would be 48. And the seventh would be 96. So I don't remember exactly if 542 asked us to do that or not, but a couple of points I really want to point out here. First of all, the N and the T of N, and then the second, just the arithmetic and geometric and how they change. We're not going to spend a lot of time with other. These are going to be the 2 families of sequences that we really focus on in this chapter, arithmetic versus geometric. Again, arithmetic adds and subtracts. Geometric multiplies and divides. If we're talking about a sequence, we're going to use N and T of N, so we know we're talking about a list of numbers. There is, by the way, we'll talk about this more later, so I guess I'll save it. But there is no 0 term, right? There is no 0 list of the number. There is no 1.5 list in the number. So just something to kind of be thinking about as we move through this chapter.